Alright, 1.7 we're going to break into two parts. This is the first part, and 1.7 deals with represent functions as rules and tables. Before we dive into that, let's take a look at a couple vocabulary words. First of all, what's a function? Well, we can define a function as a set, so it's going to be a set of numbers called a domain, containing numbers called inputs. And also it's going to have a set called the range, containing numbers called outputs. The next example here, we'll take a look at writing how to write the domain and how to write the range. Another way to define function is also for every input there's exactly one output. And again, in some of these examples coming up later, we'll illustrate that point in a little more detail. The domain is a set containing numbers called the inputs, and the range is a set containing numbers called outputs. In this example here, we have an input-output table that shows the cost of various amounts of regular unleaded gas from the same pump. We're asked to identify the domain and the range of the function. Well, the domain is going to be all the inputs. So as we do this, we're just looking, and sometimes we do like a t-chart, the x and y values. The x is also called the input. And so when we talk about input or domain, let me scratch that off. So we're looking at the domain, which is going to be the inputs. Okay. We're going to call it a set of numbers. So we're looking at input and looking at all the values for the inputs. In this case, it's gallons. So we've got 10, we've got 12, we've got 13, and we've got 17. Those are all the inputs listed. And when we indicate sets of numbers in mathematics, we use brackets, generally that look like this. So that's how we denote the domain for this particular function. So domain's the inputs, which means that range is going to be the outputs. So we're just going to go and look at all the outputs. In this case, it's dollars. All these four numbers are included in the range, so we're going to list them here. So we got 19.99, we've got 23.99, we've got 25.99, and we've got one more, 33.98. And again, this is a set of numbers, so we're going to use this bracket. Looks something like this. I'm not happy with the way that this one turned out, so let me just clean that up. Alright, and okay, that looks better. Alright, so there's the domain. Domain's all the inputs listed like that, and the output is the range. The range is the output listed like that. Alright, so determine if another way to write a function than the previous one we just saw was in a table. We can also represent it as a map, or as a mapping. And that's where we have the input and the output. As you can see here, a circle or oval that contains all the inputs, and an oval or circle that contains all the outputs. So this is saying, with your function, if you put a 1 in, out comes a 0. You put a 2 in, out comes a 1. You put a 3 in, out comes a 2. And you put a 4 in, out comes a 2. And one of the definitions that we use for functions under that vocabulary was that for every input there's exactly one output. Well, if you look at this input of 1, there's exactly one output of 0. If you look at this input of 2, there's exactly one output of 1. If you look at this input of 3, there's exactly one output of 2. When you look at this input of 4, there's exactly one output of 2. So for every input, there's exactly one output. So this is an example of a function. So this is a function. Okay. In a moment here, and when we go on to a couple other examples here, I'm going to give you an example of something that's not a function. So this is a function. All right, let's move on. Alright, so here we're asked to tell whether the pairing is a function. Alright, so if you recall, we said that a function, for every input there's exactly one output. Well, if you look here at this mapping, when you have an input of 0, you get an output of 0. And when you have an output of 0, or I'm sorry, when you have an input of 0, you get an output of 0. When you have an input of 0, you also get an output of 2. Well, this particular input has two different outputs. To be a function, it has to have exactly one. Well, there's two. So this is going to be not a function, this mapping here. And the reason being that for the output of 0, the input of 0, there are two outputs, not one. Okay. Over here, let's look, again, looking for every input, there's exactly one output. Well, when you input a 3, you get a 1. You input a 6, you get only 2. You input a 9, you only get 2. When you input a 12, you only get 1. So for every input that we see, it has exactly one output. 3 only has one output. 6 only has one output. 9 has only one output. 12 has only one output. So this is a function. And again, this is two different ways to represent functions. This one's a mapping, and this one is a table.